Hey guys, welcome back to science. I hope that you guys all watched the video yesterday and you're now able to answer the questions that your teacher gives you correctly. Remember that you really need to watch these videos. We have to have science every day. We're going to have questions every day, a quiz every week. We'll have a big unit test, and we will even have an EOG at the end of the year. So make sure that you guys are watching these videos, okay? On Fridays, we're even going to go over them and talk about them. So make sure you'll be able to participate in the conversation that we have. So far, we have learned about matter, and we've learned that in solids, the molecules are really close to each other. They don't have much energy. Once they get a little bit more energy, they move further apart from each other, and that makes a liquid. And once they get even more energy, they're even further apart from each other, and that is a gas. And then we learned that matter, once it is here on Earth, it is here to stay, but it can change. And there are chemical changes and physical changes. A physical change is not going to produce a new substance, whereas a chemical change will produce a new substance. And as we graded some of your quizzes last week, some of you said that a chemical change would be something like water evaporating. But remember, whenever anything in the water cycle is a physical change, because when water evaporates, it is still the same molecules, they just got more energy. So if you go out in the sun, your hair is going to dry, your towel is going to dry, and it's not going to be water anymore. It's going to get energy and turn into a gas and become water vapor around the air. Okay, but once you were to take that away, if you could take that heat away, it's going to condense and become liquid again. So nothing new is made. It's still the same molecules. So remember that. That's important. And it would definitely be on your test. So today we are going to talk about how heat transfers. You've all probably burned yourself somehow at some point. When I was probably about in 5th grade, we had our stovetop on. My friend and I were going to cook something, and it wasn't bright red yet, and I put my hand down like this on the stove, and it hurt. Okay? So we're going to learn about the ways that heat transfers. Before we do that, we need to remember that heat is energy. Okay? So when something has more heat, it's going to have more energy. So those molecules are going to start moving more and moving away from each other. How I remember that is when I am hot, okay, it's been really hot and muggy in Wilmington lately. When I am hot, I don't want anything near me, okay? Now, is a molecule a living thing? No. But you can help remember that when you're adding heat, those molecules are going to move further away from each other, have more energy, and be bouncing around. But when I'm cold, when you're taking away heat, you're going to come in together, well, pre-pandemic, you're going to come in and cuddle with each other to stay warm and get real close. So you can remember that when you're taking away heat, those molecules are going to come together, okay? So something to remember is heat is energy. Therefore, if something is hot, it will move faster than something is cold, and causing some things to expand. Remember, fast molecules for heat, slower molecules for something cold. All right, and you see a picture of the train tracks on here because it used to be, train tracks are metal, and they used to not have the little planks, they now have room for them to grow, to expand, because when they get hot, the molecules move just a little bit, and it's not noticeable by your eyes, but a train needs to stay right on that track. So train tracks, they're out in that sun, and it's metal, and it's going to hold heat real well, and those molecules are going to expand, and then that train's not going to fit on it anymore. So train tracks were made now to have room to expand a little bit when the train tracks get really hot and expand in that sun. So there are 3 ways in which heat transfers: convection, conduction, and radiation. Say it with me: convection, conduction, and radiation. Those are our 3 heat transfers. Okay, the first one we're talking about is convection. And how I remember the difference between all of them is convection has a V, right? Well, make a V with your arms. See my V? Make a V with your arms. And when you make a V with your arms go up. They rise up. And convection is the type of heat transfer when heat rises up. Okay? So what happens is, let's give some examples. Convection. So one example would be, a hot air balloon. Okay? So you guys can see the hot air balloon, but you can't see me. But what happens inside the hot air balloon is right underneath here, there is some fire. And that puts heat into the air balloon. And that is going to cause the molecules to spread out even further. So now all the air in the hot air balloon is lighter than the air around it because it has extra heat, and heat equals energy, and those molecules are spreading apart and becoming lighter. So now the hot air balloon is lighter than the air around it, and it's going to rise on top of the other air. And that's how a hot air balloon works. We're also going to learn that convection is responsible for a lot of our weather patterns, and we're going to talk about that when we get to weather. But warm air rises and cooler air sinks because it's heavier. The cooler air is heavier. There's more molecules, whereas the warmer air has more energy. Those molecules are bouncing around, moving around more, and it's lighter. So warm air rises on top of cooler air. And a great example, which you guys all probably have first-hand experience with, is water boiling. So you put the water on the pot, and you turn it on, and you wait for the water to boil. And the reason why we wait for the water to boil is because we want the food in there to be cooked evenly. So if I put some spaghetti noodles in there, some hard, dry spaghetti noodles, I wouldn't want half of my spaghetti noodle to be cooked and then the top half isn't cooked, it's dry. So when I drain my spaghetti noodles out, I have a crunchy and soft side to my noodle. That would be disgusting. So the reason why you wait for the water to boil is so that you know it's all hot and it's going to cook the food evenly. And then once you know that it's all hot is when the water starts to boil. And what causes that is heat rises. Why? Because you're adding energy and it's becoming lighter, and light things are going to rise to the top. Just like when you mix oil and water together and the oil goes on top of the water because it's lighter. So the water is getting energy and it's rising to the top. Okay? But you're going to keep cooking it because you want it all to be hot and all to be cooked. So now this water is going to rise to the top, and now this is getting hot and it's rising to the top. And then it's like a battle. When all that water gets to the top, it's fighting to be at the top. It's fighting, I want to be at the top, I want to be at the top. That's when it's going to boil, and you know, okay, it's all hot. It's all rising to the top and trying to get on top of each other. And now I can add the noodles in. Okay? So convection is your heat rising. You might have noticed it at, if you've ever gone to a pool or the ocean, you might notice that you dip your foot in the top of the pool and it feels decent, it feels pretty warm, it's all right, I'm going to jump in. And then you jump in and the bottom of the pool is cold, or it's cooler. And the reason is because the warm water is going to rise to the top. Why? Because it's lighter, so it's going to make its way to the top. And the cooler water is going to go to the bottom. All right, conduction. All right, how do I remember conduction? Well, conduction, this little Dutch right here, okay? Dutch sounds like touch. And conduction is heat transfer by direct touch. So earlier I made the reference of me putting my hand on the stovetop burner when I was your age, and it hurt my hand. Well, my hand was directly touching the oven, and so the heat transferred, that energy in the stovetop transferred from the stovetop to my hand through direct touch, and so it made my hand hot. And then to take it even further, now that my hand's hot, I could touch it to my face. And that is also direct touch because my hand is directly touching my face. And the energy is going to transfer to my face. So conduction is transfer of heat, a transfer of energy through matter from particle to particle. For example, a spoon and a cup of hot soup. Now you stick your spoon in the hot soup and your spoon gets hot. Oh, you just burnt your lip. You just burnt your tongue. Because the soup, the hot soup, directly touched your spoon. And then to take it even further, the spoon directly touched your mouth and that made it hot. The best conductor of heat is going to be metal. So metal is the best conductor. And you know, when you guys are cooking, if you want to go cook some cookies this afternoon, okay, you're going to take your cookies, you're going to mix everything up, you're going to take your spoon and scoop them out. Are you going to scoop them out onto a piece of paper? No, because if you put paper into the oven, that paper is going to catch on fire. Are you going to scoop those cookies out onto some plastic container that you have that maybe you're going to plan on keeping the cookies on? No, because that plastic is going to melt. Chances are you're going to put the cookies on a metal baking sheet because metal is a good conductor of heat. It can withstand heat without catching fire or melting. All right, so some examples of conduction. We have, of course, the example of the baking sheet. You and if you're going to get the cookies out of the oven, that would be conduction. Okay? If I go to grab the baking sheet out of the oven with my bare hand, is that going to feel good? No, it might even send me to the hospital. So you see that this person has an insulator on their hand so that it doesn't burn their hands. We have the hot soup, the soup spoon and the soup getting hot. We have something directly touching the flame, so that is going to get hot. So I don't know what this is a picture of. It's maybe some sort of metal rod. So the metal rod is going to get hot, but but this hand is touching the metal rod, so that's going to get hot because that energy is going to transfer, and that's conduction. And finally, we have radiation. And you guys have probably heard radiation before. There's a lot of different types of radiation. And radiation is feeling the heat through electromagnetic waves. So if you go outside and you're standing in the sun and you feel that heat, okay, are you touching the sun? Absolutely not. That's impossible, but that would be conduction. Okay? Are you hovering over the sun and the heat is rising up? Nope, that would be convection. You're feeling the sun from very far away because it is traveling through electromagnetic waves. Another example of radiation is if you like to go camping or have campfires. So if I were to directly touch the fire, don't ever do that. That would be conduction. If I were warming my hands over the fire, that would be convection. But if I am next to the fire and I'm feeling the heat from the fire, then that is going to be radiation. It's traveling through electromagnetic waves. So right now I'm going to sneak in your little question that you're going to have to make sure that you're watching the video. So my favorite thing to cook over a fire is marshmallows. What is your favorite thing to cook over a fire when you're going camping? I really love marshmallows, but I do hot dogs, corn, all of anything, classic, easy, when we go camping are the best things. And then we can also do examples of all three. And you're gonna, you'll have questions where it might be hard to, differentiate. Is that convection, conduction, radiation? Well, there's gonna be times when it's all three. For example, the pot getting hot is directly touching the burner, so that is conduction. But when that water is rising, and that it would be convection. Then if I were to be standing over here and feeling that heat because I'm just near the pot in general, that is going to be radiation. Another example of all three. So conduction, we see they have some sort of metal rod in the fire. So they probably are going to, get ready to cook a hot dog or cook a marshmallow in the fire. So that metal rod is directly getting hot because it is directly touching the fire. In return, you see that this person has a glove on their hand. And the reason that they are wearing a glove is because your metal is a good conductor of heat. It's going to hold that heat well. So the energy is going to go from the fire to the metal rod, but it's going to travel down the metal rod to their hand. And that is, they're going to need to have something so that they don't burn their hand, some sort of insulator. So that would be conduction because their hand is directly touching the rod. Convection is warming my hands up over the fire because the heat rises. And the radiation is warming my hands next to the fire. All right, we're going to take notes tomorrow. I know this was a longer video, so tomorrow we're going to be taking notes on convection, conduction, and radiation. So make sure tomorrow you come with a paper and a pencil, and also make sure you answer your question for Tuesday's video so we know that you're watching them. All right, guys, see you later.